Hey everybody, today we're going to look at exponential functions and a couple behaviors, and then also how to graph. So just to start out with, an exponential function will always look like y equals a to the bx. A couple stipulations: a cannot be 0, and then b has to be greater than 1, or has to be greater than 0, but it cannot be equal to 1. Our parent function, so the most basic graph we could have, would be y equals b to the x. And then I graphed those two different options. So here would be our two parent functions. The first one is if b, so the graph on the left is if our b value is greater than 1. It increases. If our b value is between 0 and 1, so we're thinking about a fraction, it's going to decrease. Okay, so those are your two options for a parent function of an exponential. Okay, we have something called an asymptote. And an asymptote is kind of like an invisible line that your graph's going to approach, but it won't ever touch. So if you think about that parent function that we just had, this graph appears to be approaching the x-axis, but it gets really close and never touches. That means that our x-axis, or y equals 0, is a horizontal asymptote. Okay. Just another key point to make note of: the base of our exponential function has to be positive every single time. The base will be positive, but the exponent itself could be negative. If that happens, if we have a negative exponent, we can always write our base as a reciprocal to that same to the positive power. So for example, if we had 2 to the negative third, we could rewrite that. In order to make our exponent negative, or in order to make our exponent positive, we could rewrite our base as 1 over 2, the reciprocal of 2, and then our exponent is positive. If we have a fraction to begin, so we have 4/5 to the negative second, in order to make that exponent positive, we're going to write the reciprocal of 4/5, which is 5/4. Okay, now we're going to graph the equation y equals 2 to the x. Now, we can do it the old-fashioned way and make an xy table. So all that I have done is chosen some x values, and then in order to get the y values, I've plugged those x values in. So if you plugged those x values into your exponential, you would get those y values. And then I went ahead and plotted them. So here's our graph y equals 2 to the x. Just a couple key things that we'll point out on these exponential graphs. So we'll be asked to find the domain and range. So our domain of this function, remember, we're looking for x values. So there's no restrictions on our x values. Therefore, our domain is all real numbers. Our range, however, must be positive. Notice this graph will never cross the x-axis and become negative. So our y values have to be greater than 0. And then sometimes you'll be asked to find an asymptote. And our asymptote here would be our x-axis again, which we need the actual equation. So that's y equals 0. From here on out, you won't have to make XY tables unless you prefer it. I'll allow you to use Desmos to make this rough sketch. Okay, last kind of new information, we're going to look at transformations to our exponential function. So we have our parent function, y equals b to the x, and we're going to look at different transformations of that. So if we have y equals a times b to the x, we're going to have a vertical stretch if the absolute value of that a value is greater than 0. It'll be a vertical compression if that a value is a fraction, so between 0 and 1. And then it'll be a reflection over the x-axis if that a value is 0. And then here's a different type of transformation. If we have anything extra in the exponent, that becomes a shift left and right. And then if we add anything to the end, that's going to be a vertical shift, either up or down. So these two are very similar to what we've talked about. Actually, this top transformation is similar to what we've talked about in the past as well. So here's an example. We have y equals 3 to the x as our parent function, and then we have this exponential function as well. So we have a 1/5 times, and then we have an x plus 2 in our exponent, and then a minus 7 at the end. So I'm going to move left to right. This 1/5 would be a vertical compression because it's between 0 and 1. X plus 2 is a shift left 2 units, and then minus 7 is down 7 units. So just some key things from this lesson. What you're going to be asked to do is to be able to graph and then sketch the graph that you've come up with, and then also describe any transformations that occur in the graphs. So here's just an example, and remember, in order to sketch these graphs, you can use Desmos, so you can just type all these in, but you would graph all 3 of these and then describe the graphs compared to the parent function. So here, this would be our parent function, and then our last 2 equations are different transformations of that parent function. But you might be asked to graph them all on the same coordinate plane. You might be asked to find the domain range and any asymptotes, and then also to list any transformations that occur.